And let's move on with another interesting presentation on scaling machine learning together with Monika Venckauskaite, who is MLOps engineer at Vinted, the known Lithuanian unicorn. Monika's first experience with machine learning was analyzing. He was working at CERN laboratory, and she worked with antimatter analysis at CERN and neutrino detection at Oxford University at Fermilab laboratory. A smart woman, isn't she? Later, she continued using machine learning in cybersecurity, where she developed applications such as OSINT, an open source intelligence tool to analyze data available on the public internet. She was aimed to fight fake news, propaganda, and people trafficking on the internet. Currently, Monika is working in a field of MLOps at Vinted, company aiming to make second-hand fashion a first choice. She and her team make sure that machine learning models are being shipped fast and efficient and accurate. She also ensures the data scientist can have a comfortable environment in order to build analysis that promotes second-hand fashion for a sustainable planet. So welcome, Monika.
Hello.
Hello. So you are the first female AI ML engineer today on this stage. So I'm super happy to have you here. And maybe let's touch on this topic a little bit. What about the diversity in your team?
Okay, so I'm delighted actually to be the first speaker today. I would say women in machine learning are not uncommon, but still we have this is a field very much dominated by men. So in my team, we are about 5 people in MLOps. So I'm the only woman, but we have in our company, we have quite a few data scientists and machine learning engineers who are women. So I think the interest is growing, and I'm happy to hear that. And also, since you mentioned this, so if anybody would like me to reach out to learn more about how is it like to work at machine learning, you can find me on LinkedIn.
Amazing. A great advertisement spot. And now we're ready for your presentation, Monika.
Okay, thank you. So I'm glad that this year we have such a diversity of different topics. And today I would like to talk with you about scaling machine learning and why it is important. Actually, when we start working with models inside a company, well, at first we ship a few models, we learn what is working for us. But later we realize that, well, we'll have eventually a pile of models that we have to be aware of, like the data they use, the quality they are, and possibly the future directions they should go as well. So, well, considering this, we also need to monitor the ones that are being used in production. And recently, like during a few years, some techniques emerged, how to deal with the models in production, especially when you want to ship them continuously. So it's called MLOps, and what it is today, I'm going to talk with you a little bit. So we're going to be designing for speed, efficiency, and innovation. So very briefly, my talk is organized in 4 main parts. First of all, we're going to touch up a little bit what is MLOps, where it's coming from. Then we're going to dig in a little bit deeper to the 4 pillars of MLOps. So basically, which areas it does touch up on. Then I'm going to introduce you into the zoo of MLOps tools, which is these days it's quite wide and vast, and it's ever growing. So don't be overwhelmed. Just you can explore some of those tools yourself as well. And lastly, I'm gonna talk a bit about how does Vinted solve machine learning problems for our millions of users platforms, since we have quite a few problems. First of all, we have to scale well. We also have to be accurate, efficient, and fast, because usually we need to serve our users in a matter of milliseconds. So yeah, let's continue. What is MLOps? So in order to talk about MLOps, first of all, we rather remember the whole machine learning pipeline. So most of you know that everything starts with data. In order to train any machine learning model, we need to have a quality data to prepare it to suit our use case. Then there's model training. Model training these days can happen in many languages and many frameworks. So there are already many libraries helping us here. Then the train model must be packaged. It's usually packaged together with all the data transformation is performing on the data. Because, for example, take a real world case scenario, we prepared the data from our raw data set. Well, of course, we're gonna get the raw data from our application in real time, so we need to perform the same data transformations. And then again, we need to validate model. Validation can be pretty strict depending on our use case. If it's a model that's very sensitive, for example, if you would have a credit risk assessment or something like that, it has to be very accurate. So it has to pass a few benchmarks. For us at Wintet, the very common benchmark actually is its speed. Is it fast enough? Does it make inferences fast enough so our users could be served in real time? And then the next step is deployment. There are a few approaches how to go about this. One of those is to automate the deployment. In a way, it makes sense. If our model passed our benchmarks, we can automate the deployment, like to let it go into production. But many companies, including us, are choosing a bit more careful approach. So we are still having a human in the loop, which is accepts the model. So if its model passed the test, it has a good quality. And we are aware that such a model has to be deployed. Then our MLOps team engineer just lets it go to the production. And then once the model is production, we monitor various metrics. We check, is it performing good enough? Also, we investigate data. Does data change? Because if data changes significantly, there are some scenarios where we would need to retrain our model to suit the new state of life, basically. And data can change. The common ways it changes actually as seasons go by, user habits change. Maybe our user population has changed. Maybe they grew a bit older. They have different shopping habits and so on. So there are many reasons that data could experience a drift. So to summarize, MLOps actually encapsulates the three big areas of software development. First of all is, of course, machine learning with all its specifics. I already mentioned accuracy, but also we would need to be aware of other metrics and parameters that are in the play. So for example, error rate, or also we have to know how to help our platform users to tune the hyperparameters. So we need to be quite knowledgeable about machine learning side as well. Also DevOps, the traditional DevOps practices, also continuous integration and delivery, which is very common from traditional software development. And lastly, data engineering, which touches up on the part how we work with data. Usually we have raw large data sets that we need to transform, to brush up on them. And for that, we also need convenient tools. So MLOps encapsulates all of those three areas. And speaking about the process, it also comes in all the lifecycle processes of machine learning model. This is a more like general version of them. So the first one is design, the way we design our analysis, the way we formulate our hypothesis. MLOps already starts coming in, helping us with the statistical tools and also ways of working with data fast, because we have if we have a huge amounts of data, we need to learn how to work with it in parallel, so we could be fast enough. And then the second square here is model development. So here we have quite an experimentation phase. Building an initial machine learning model is fast enough, but we aim to build it good enough to be accurate and good enough for our use case. So here our MLOps comes in helping with experimentation and comparison of different models, so you could pick the best one. And then finally, in the operations stage, we check data drift, and also we monitor model quality, whether it's degrading or not. So coming back to our real-world use case of MLOps, I would like to comment about machine learning lifecycle with our certain use case in mind. So for example, we have an application. Also, we could have it on the phone and on the web, which sends out some data about user behavior. So first of all, we would need to have a proper data acquisition system. Data acquisition system has to be fast, and it involves heavily working with data. So in our case, for example, we store data in Hadoop cluster, but there are also other solutions available. So yeah, data acquisition system needs to be fast, reliable, and also it needs to be fast enough for the machine learning user. The next stage is data preparation. Here our engineers already work quite independently, but you could also have a data engineer working here. So this area is a bit of a bridge between machine learning and data. Here we assess the quality of data, try to fix the bugs in data, find clean it up a bit, brush it up, and also the engineer picks up the data they need for the analysis. And the next stage is hypothesis and modeling. Hypothesis is pretty much mandatory in most cases, meaning that it helps to direct your research, your analysis in such a way so you would know that you predicting something and you would be clear on your end goal, so you could develop a good model. And next stage is also evaluation and interpretation. How model is working? Is it working well? Is it unbiased? Is it accurate? Did it predict it, for example, the clothing pieces in an image good enough? And then if models are good enough, here comes the deployment phase. Deployment, we must ensure that it would be highly scalable, since we are running a multi-million user app. So in our case, Kubernetes helps us to deal with the scaling. There are some particularities involved on how to scale them, how to scale machine learning models. But in the big picture, Kubernetes handles the most hard work for us. And here comes the operation stage. Operation tells us about the quality of the models we are running, whether they're degrading, whether they need to improve, also whether they are alive, basically, but because in certain cases they might break as well. So we need to be prepared, we need to be aware of that, and we need to track everything of that. And if models are degrading, or if we realize that with current techniques you could build a better model, then here comes an optimization stage. So we have quite a few models which are being continuously improved. For example, our spam detection model is always learning on the latest news from our platform. So digging in a little bit deeper, you already noticed that MLOps comes in various stages of machine learning. Basically, it aids all of those stages. And talking about MLOps itself, we could name 4 pillars of MLOps. One of those is automation and continuous integration, continuous delivery pipelines, which is quite similar actually to traditional software development. But here we just like ship machine learning models and test them in a way we can. We also deliver code around machine learning. Maybe there's like a custom pipeline being built. It's also being reviewed in our continuous integration delivery process. The second pillar is feature store. It's not like the base of every MLOps, but in recent years it's gaining popularity because it makes creating machine learning models faster in a way that it speeds up the data processing time. So you imagine if you're working with models like over and over again, maybe you are using the same features, maybe you are brushing the data in the same way, maybe you are building some data sets which would work for multiple models. So feature reuse is a common thing which helps to speed up your process. And for that, we have a feature store. Feature stores can be offline or online, or both offline and online. The most advanced ones can combine both functionalities. So it can also let you work with data in offline mode and as well share them, your built features in online mode for production. The third pillar is testing and monitoring. So you need to test and validate the incoming data and features, and also the models. Monitoring can be carried out in a few ways. Usually, commercial machine learning platforms have something built in. Open source ways would be using Prometheus and Grafana as well, and also performing tests, whichever you need to. Possibly you need to build a custom test. And the fourth pillar is versioning and reproducibility. You need to version everything you're creating so you could improve on what you built before. And also imagine the situation where some scientists built a model inside your company and then suddenly they left and the model was left with no documentation. Model without documentation, it becomes worthless in that case because we cannot know enough about it to see how useful it is and also to follow up on its development. So versioning is mandatory and it can also debug issues as they arise. For example, if further generations model, if they would fail, you could also just revert back to the previous model version and continue working in production. On the same time, debugging and tracing what went wrong with the new version. So versioning is also goal of MLOps. And so I mentioned many features MLOps must cover and offer for data scientists, but actually it's not that bad. There are quite many tools on the market as well. I call it the zoo of MLOps. So here I have all the 4 pillars of them. So the biggest cloud providers actually do cover most of those features. However, some more advanced features from feature stores might be coming from like separate vendors. So here, for example, we have continuous integration, continuous delivery pipelines. We already use in our platform MLflow and Kubeflow for model versioning as well for building pipelines. But you could find similar solutions inside cloud providers as well. As it comes to feature stores, also there are many of them, of very different providers. Also, Feast is open source one, so if you want to build your MLOps stack yourself at home, you can do that too. For testing and monitoring, we use Grafana and Prometheus. There are also other options available. And for model and data versioning and reproducibility, as I mentioned, we use MLflow, but other tools offer similar functionality. So feel free to explore those. Some of them are not open source, but most of them are. So you can build something that works uniquely for you. There I would say there is no general solution that works for everyone. You have to find what works best for your company, for the size of your team, and for your processes. So the last part, how does Vinted solve machine learning for our millions of users platform? So first of all, some fun facts about Vinted. We are already operating in 13 markets, and we will continue to expand. We have 45 million users as of today, and we are sure we will be growing in the future. And for us, it means that we're gonna have about 60,000 requests per second as for now. And of course, every hour this number is growing as we are acquiring new users. So this is a problem of quite a big scale, and we also need to serve our users with quality and with speed. So for us, it meant that we have to solve our MLOps internally the way it suited us. We built our own platform in Python, which is modular. First of all, we have our data warehouse in Hadoop and Spark. So Spark helps us to query our data fast. And the custom components we built first of all a training component in Python, which is also uses MLflow and kubeflow and helps engineer to only mine the model architecture and not the rest of the parts of the pipeline. It automates this process. Then there is another component which helps with fetching resources for our models. We are training on Google Cloud for now because it helps us to get the resources on demand. We have quite demanding models. Very often they involve the image recognition. We are working with clothing pieces inside images. So we need to sort them into categories to detect their colors and so on. So our models quite GPU intensive. And this is what we can get on Google Cloud. And our component helps to fetch the data from our on-premise warehouse to Google Cloud, as well as to fetch the libraries needed, which are helper libraries for training. And the last component is used for deployment. Basically, it's also built with Python. It's a server component helping us to get information about the model, which we further send with Prometheus to Grafana, so we could check the liveliness, the health, and the quality of our models. So how does it look like in the big picture? Here you can see the architecture of our platform. At the bottom left corner, here is our data warehouse using Apache Spark. We query data with a data getter, and also this is our first Python component, which helps us to fetch the data. And then we have a model trainer. Model trainer can work with multiple frameworks, including PyTorch, TensorFlow, Scikit-learn, Fast AI, you name it. So we use quite a few of them. People are also building models in R and Scala as well. So we have a very varied machine learning culture. Our scientists use what suits their purpose the best. And here we have some model metrics already. We got some metrics, some visuals, and define some models and train them. And after we train them, we ship the artifacts to our third components, the server builder, which builds a container around our model artifact, which includes a server, helping us to measure the quality and health of our model, as well as track does some logging for metrics. And when the server is built, it's pushed to Google Cloud Container Registry. So here we keep images of our service. And we also have here a human quality check step where we check whether whether model passed all the needed checks, whether it's accurate enough, precise enough, does it have good quality, does it make sense for its deployment, so we don't have any stray models. And then we deploy it. Here we have Docker Swarm. We used to have Docker Swarm. For now, we're using also Kubernetes to have it scalable and available on demand. Yeah, and then when it's in production, it's being integrated into our core. Our backenders also make some work, so our customers could use some model through our app. So if you're using Windows app, you possibly uploaded a picture and had your maybe noticed like the how the images are falling into the different categories. So our machine learning engineers already did work, great work to make it happen for you. So images are usually classified. You have a search, which is based on our data from machine learning models. It helps to make it more accurate. It helps you find your pieces faster. Also, we have a recommendation engine which helps for both the buyer like to find what they need faster and for the seller to sell their clothing items fast. So quite some work went into this one, into bringing quality service for vintage. And we, of course, will continue to evolve our platform to use the best tools, also to make it faster, to enable more powerful models. So, for example, if you have like higher computing power, we can have a more powerful image recognition models, which do better work. And we'll for sure continue to grow in this direction, as well as exploring new and advanced tools on the internet. And to summarize, I would like to say that MLOps field is ever growing. It's very rapidly changing these days. There are still plenty of new companies coming into the game, offering new type of solutions, new platforms. So it's still in its primary years, I would say, where it's very dynamic and growing. And what is coming in the future, we cannot tell everything. Like maybe the newest, hottest things, of course, are like feature stores and so on. But there might be some new approaches which we cannot imagine now. So it's a very exciting field. So if you're thinking of exploring it, I actually recommend it. Because if you're creative, if you like to build systems, if you like to work in the area where there are many unknowns, this is a place to go. I hope you liked my introduction about MLOps, and now it's time for questions.
Thank you very much, Monika, for sharing your insights and vintage experience. But I believe for our viewers, it's interesting to learn not only about successes, but also about some failures on the way. As we know, great results do not come without an effort. And of course, they do not come from the first shot. So maybe you have something to share from your personal experience.
We actually had some problems which we solved. So the current platform you see wasn't born like in a day. It was built up on the biggest problems we have. So I think that problem number one is how to work fast and efficiently with data. So before we had Apache Spark, it was very problematic because working like, as you can imagine, with gigabytes of data is very memory demanding, and without Spark, it's very slow. So this is one of the biggest problems. And I think another one is maybe being also like scalable in a production. So Kubernetes is actually a good helper. But before we developed our production system, we faced also a few problems. For example, machine learning models, when they start up, they need way more memory when they are working in a production. So we had also to tune our Kubernetes cluster to work well, because the way Kubernetes works, it simply scales up where the resources are needed. So for example, if you have like very memory demanding model, it asks for more resources, but it only needs it for like a few moments in time. So we had to go through knowing, through experimentation, I would say, and knowing what we need to achieve, and basically being in touch with reality all the time. We developed something that solved those main pain points and works for us.
Thank you. And we have a couple of interesting questions from our audience, some of them quite technical, so get ready. Are you using GPUs to speed up the inference in production?
Yes, so we have a few image recognition models, and we are using GPUs both like for training and for inference.
And the other question comes from Audrus, and he is asking, the European Commission proposed Artificial Intelligence Act in April 2021. According to this act, there can't be errors in AI models. So is it possible to implement it in practice? What is your opinion about that?
Yeah, so the way we are going about it, we are trying to make them as little biased as possible. So one of the way of trying to solve that is basically to look how much importance each feature has in your model. So as far for image recognition, for example, we don't work with the people data, so we are safe here. But in general, we try to be as transparent as we can. So feature importance as well as the distribution of the final predictions tell us already, does our algorithm lean towards a certain user group? Does it favor something? And how much importance each feature has? So we are sure gonna be working on making our models transparent and having them as unbiased as possible.
Great. So thank you very much for your answers. The time is up for today, but we hope you stick with the conference and we'll learn from other speakers too.
Thank you very much. My pleasure.